So this is chapter 3, lesson 6, number 15, and today we're going to go over the concept of finding the distance from a point to a line on a coordinate plane. And this is done by Lauren, Bailey, and Ashley. So that's our concept to find the distance. And number 15 tells us that line L contains points 0, -3, and 7, 4. And point P has coordinates 4, 3. So first we're going to find the equation of line L. So we're going to do that by finding the slope of line L, which is 0, -3, and 7, 4. And we're going to do that by using the slope formula, which is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we're going to plug in our coordinates, and we get 4 minus -3 over 7 minus 0. We simplify, we get 7 over 7, or 1. So then we are going to plug into an equation using our point 7, 4 to find the equation of line L. So first we're going to use the slope-intercept form, which is y equals mx plus b. We're going to plug in our coordinates. We get 4 equals 1 times 7 plus b. And then we multiply 1 times 7, we get 4 equals 7 plus b. Then we subtract 7 from both sides of the equation to get b equals -3. So after that, we find that the equation of line L equals y equals 1x, or x minus 3. So now we want to write an equation of the line W, which will be perpendicular to line L through points 4, 3. Now we do the perpendicular line because it is the shortest distance from the point to the line. And again, we're going to use the slope-intercept form, which will be y equals mx plus b. And we plug in, we get 3 equals -1 times 4 plus b. And this time we're using -1 because it is the opposite reciprocal of our previous slope in line L. So then we simplify, we get 3 equals -4 plus b. And we add 4 to both sides, we get b equals 7. So then we find that the equation of line W is y equals -1x, or -x minus 7. So now we need to find the point of intersection between line L and line W. Now we're going to do that by solving the systems of equation to determine the point of intersection. So we're going to add our two equations together, which is y equals x minus 3 plus y equals -x plus 7. Now x and -x will cancel out, and we will get 2y equals 4. Then we're going to divide 2 by both sides, and we get y equals 2. Now since we have y, we're going to plug into one of our equations to find x so we can get our coordinates. So we are going to plug it in, and we get 2 equals x minus 3. We add 3 to both sides of the equation, and we get x equals 5. So now we are going to, our point Q, or point of intersection, is 5, 2. And now we are going to find the distance between point P, which is 4, 3, and point Q, which is 5, 2. We're going to do that by using our distance formula, which is d equals radical x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We're going to use our two coordinates and plug them in. We will get d equals radical 5 minus 4 squared plus 2 minus 3 squared. We're going to simplify that and do our math. We will get d equals radical 1 plus 1. We'll do our addition, and then we find that our distance, or d, equals radical 2. Now, our distance is radical 2 because we figured out the systems of equations from line L and W, and we used those coordinates and our point that they gave us in the beginning, and we found the distance between each of them. So we will find that the distance between the point and the line is d equals radical 2. So it'll be radical 2 units.